Hey everybody, Mr. Buggo here with problems 8 through 10 on your Algebra Chapter 7 self-test. In 8 through 10, we're using the following information: that a particular new 2006 car costs $34,975. And we're going to suppose that its value depreciates, means that it's going down 16% every year. So we want to find what is the growth factor of the value of the car. Well, we need the interest formula here, where the total amount is equal to the principal amount times 1 plus the interest rate to the t power. And we have some information here that we can plug into the equation. We can plug in the principal of $34,975 because that was the cost of the new car when the car started. And then we can plug in this minus 0.16. And it's a minus 0.16 because it is depreciating 16% each year. So it's going down 16% each year. It's losing 16% from the 100% of its value after t years. So the growth factor is going to be, if it's losing 16% of its value, how much of its value is it maintaining? And by simplifying what's inside the parentheses here, we find that growth factor. So in this case, the growth factor is 0.84 because the car is maintaining 84% of its value every year. The growth factor, again, is the base of the exponent in an exponential function or equation. So in this case, the growth factor is 0.84. Number 9, we're going to write a function, and we're going to call it m of x that approximates the car's value in x years, and we're going to specify the domain. So we'll talk about that a little bit. So here's our equation right here that we just came up with in the last problem, where the total amount of the car is equal to 34,975 times 1 minus 0.16 to the t power, but they want it in function notation in terms of x. So these two equations are exactly the same thing. There's nothing different about them except that the way that they're written. This top one is written as an equation. The bottom one is written as a function, or in function notation in terms of x. So we plug in how many years have gone by, and we can find out what the value of the car is after x years. The domain of any function is all of the possible x values you can plug into the function. So if we're talking about the car here, value of a car after x years, the domain has to be any whole number. Because if we talk about how many years have gone by, we're not going to say 1.2 years, we're not going to say 2.5 years, we're going to use an integer for years, and it's got to be a positive integer, leaving us with any whole number. It's not going to be a fraction, it's not going to be a decimal, it's not going to be a negative number, because we're not going to go back in time before 2006 to find the value of the car. We can't go back to the year 2000 and see that the car is worth maybe $80,000. It doesn't make any sense for a car to be worth more than what it's worth before it even exists. So it has to be any whole number is the domain, because the only numbers we can plug in for x that would make any sense for the context of this equation have to be a positive whole number. And number 10, we're going to find m of 5. So now all we're doing is evaluating a function for the function at the value of 5. So here's our function we had last time, and I put in a 5 there. This should be an x. So it should look like this, kind of jump the gun there a little bit. So this is m of 5 equals 34,975 times 0.84 to the 5th power. So right here, this 5 should be an x. That's my mistake. This is what we have if we plug in 5 for the value of x. And then we're going to use a calculator to evaluate this. I have no idea what this is. I don't know what 0.84 to the 5th power is. I needed to take out a calculator to evaluate that. And upon evaluating that, we find that m of 5, when we plug in 5, we get $14,626.96. So when we plug in 5 into our function that we wrote for the value of the car after x years, we get $14,626.96.